Welcome everybody to our TeachMeet this evening, recognising and supporting Dyscalculia. My name is Peter Mattock, and having been a maths teacher for 20 years, I am now the National Education Lead in Secondary Maths for Twinkl Educational Publishing, and I'm joined by my co-host Jon.
Hello everybody, thank you for joining us. I have also been in education, not quite as long as Pete, actually about 18 years. As maths lead, assistant head, and various roles with maths hubs and things. So yeah, looking forward to this session, Pete.
Yeah, absolutely, Jon. It's going to be a good one. Right. Yes, so we're going to be talking about recognising and supporting Dyscalculia. And I guess we should start with what is Dyscalculia? And this was comes from guidance that was updated recently by the SASC. And we put a link to that, so when you get the slides and the recording later on, you can have a look at that should you wish. And there's a few key messages in this definition. I'm not going to read the whole definition to you, but there's a few key messages in this definition. First of all, the difficulties that appear with dyscalculia are age-related. So the sorts of things we're looking at, many pupils might struggle with when they first encounter them. You know, it's not a case of everybody who struggles with this the first time they see them is automatically going to be, you know, somebody you might think of as dyscalculic. This is age-related difficulties. It's the sort of thing that even when other kids of that age have really sort of generally got to grips with this, these people might still be struggling. The second thing I want to highlight in this is persistent. Yeah, in dyscalculia, these difficulties are persistent. They're not going to go away. They're not going to be overcome. Yeah, kids might find strategies to work around them, and you might support them with that, but these are going to be persistent difficulties that remain over the time that they study maths and beyond that into their adulthood. And then the key sort of things that show up dyscalculia in particular, that dyscalculics will have difficulty with, are the ordering and comparing of physical quantities and numbers, estimating, and place value. So there are lots of difficulties, both general and specific to maths, that students may have that may impact their ability to learn mathematics. Dyscalculia in particular, the most commonly observed cognitive impairment relates to these three areas. And just to mention as well, you know, what we're talking about here is about 5 or 6% of the UK population. We're talking about, relatively, generally speaking, 1 or 2 pupils per class of 30 are going to have this. Now, obviously, if you've got streamed or setted classes, that might be balanced more in some sets than others. But in mixed ability classes, primary age classes, you're talking about 1 or 2 in every class that you might find exhibit these things. It will often come alongside things like dyslexia or ADHD or dyspraxia, but these things in particular might highlight someone who's dyscalculic. Now, I do want to say at this point that when we go through this, we're not going to be, you know, saying you can go and identify kids with dyscalculia. Yeah, you need specialist assessors and all of the rest of it to actually sort of get towards a diagnosis. So we're not looking at diagnosing here or things like that. What we are going to do as part of this course is, or part of this session, sorry, is say, okay, well, if you see kids that have age-related and persistent difficulties in doing some of these things, these are the sorts of kids you might want to pay attention to. These are the sorts of kids you might want to notice. These are the sorts of kids that you might want to be having conversations with other people in your school about strategies and referrals, because these are the signs that might indicate there's somebody you want to take a closer look at.
Thanks, Pete. So just to reiterate then, the 3 sort of main areas that we're going to be looking at in this session: naming, ordering, and comparing physical quantities or numbers, estimating, and place value. So we're going to have a little bit of a look at what difficulties how they might sort of come about, what they might look like in the classroom in those particular areas. and then we'll move on to ways that we might support any children really that display those difficulties with those particular areas. So one of the earliest indicators that you might come across, even in early years foundation stage into year 1, is difficulties with seeing quantities and recognizing quantities. And one of the first ways that this might evidence itself is difficulties with subitizing. So if you've come across subitizing before, you'll recognize it as the ability, almost sort of the innate ability that humans have really to recognize small quantities of numbers, small quantities of objects, generally up to about 5 objects really, without having to count them. That's the key thing. So I'm sure if you look at the cars on the screen there, you'll very quickly, without having to possibly count each individual one, recognize how many cars are on the screen. Somebody with dyscalculia would find that very, very difficult. Moving beyond just subitizing, comparing quantities as well, even looking at these two distinct quantities here. Somebody who has dyscalculic tendencies might find this particularly difficult to say which group is larger, which group has the larger quantity here. So those are sort of the first sort of 2 areas really that we might look at. Another way that dyscalculia might be evidenced is through problems with counting. So for anybody who studied at university, if you remember from your maths lectures, if you did a primary PGCE or primary BEd, I'm sure Gelman and Gellistel, you might remember a piece of research from the 1970s, which focused on, well, sort of evidence 5 key areas of counting. So those were one-to-one correspondence. Essentially, each object is assigned one and only one number word when you're counting them. So children will point to objects as they're counting and count them 1, 2, 3, 4. Anybody who's worked with very young children will know that that sometimes takes a little bit of practice to get. Remember what Pete said earlier, that these indicators are age related. So a young child who is finding it difficult to assign one-to-one correspondence to a set of objects, that would not be atypical. That wouldn't be unexpected. However, if after practice and as they get a little bit older, we're still finding problems with that, that might indicate that there may be some dyscalculic tendencies potentially. The next thing would be the stable order principle, which is that 2 always comes after 1, 3 always comes after 2, etc. And we count in that particular order, and they never change. Cardinality tells us that the final word that we count gives us the final quantity, and that doesn't change. So if I count 5 objects, as long as I don't do anything to those 5 objects, the next time I come back, there will still be 5 objects. Abstraction is the 4th area. Essentially, anything can be counted regardless of type, whether it's physical or not. And the order irrelevance principle tells us that those things can be counted in any order and still get the same total. So the reason that we've gone back over these, or gone over these for the first time potentially for you, is just to try and unpick a little bit what a specific difficulty might be with counting, because there's quite a lot of research that suggests that people who have dyscalculia may have difficulty with one or more of these particular areas of counting, and that might manifest itself quite early on. As I say, I wouldn't necessarily be thinking that a child in reception, certainly at the start of reception, has got a particular difficulty because they're finding one of these things tricky. But as they move into year 1, certainly you would expect at that age that these things would be in place. So just an example here, a child counts a group of 5 objects, 1, 2, 3, 4, 5, no problem. But when asked how many there are, they start to count again to find out that there are 5. That might suggest, potentially, that there is some difficulty with the cardinality principle, the understanding that the last number counted represents the total quantity of the set. Potentially. So just one of the first things that we might look out for.
And then as kids start to get a little bit older, then we will start to introduce them to number lines, and number lines graduated in different units, in this case tens, but ones, etc., etc. And one of the ways that that dyscalculic tendencies may show up when starting to work with the number line and starting to get familiar with the number line is particularly when the single marks are not between the sort of units like this, so there's no 11, 12, 13, 14, etc., is being able to accurately place other numbers on this number line, or at least get them in the ballpark. You know, if I ask a child to put place the number 28 on this number line, there comes a certain age where most kids will be able to do that, and your kids that are showing those more dyscalculic tendencies are going to be struggling to do that. Or what they might be doing, and I'm sure people have seen this before, is they might be trying to get to 28 by filling in 21, 22, 23, but then coming up way too short, you know, maybe squashing most of those into the first half of the number line, or even, you know, getting to 25 when they're massively close to 30, and that sort of thing. Working on that, you know, working on where numbers are in relation to each other, that comparing of physical quantities and that ordering is one way that you might notice that kids have got these sort of tendencies. And then even where, particularly when represented with abstract symbols like this, even when the numbers are, you know, quite far apart, if you're asking pupils to you know, insert the correct symbol here, is 42 greater than 18 or less than 18 or equal to 18, a dyscalculic child may really struggle to identify which of those two numbers is the greater number when written in symbols. The symbols just don't convey that same meaning that they might do for other people. And so, you know, asking them to order those, asking them to decide which one's bigger, even though they are wildly different in size, might not be something that they find particularly comfortable, and it might be something they find particularly challenging. Like I say, particularly when expressed in numerals like this. When we come on to the next one of those then, which is estimating, we've got a situation like this. Ed wants to buy a loaf of bread that costs £1.39, milk that costs £1.58, and a box of cereal that costs £3.74. Ed has a £10 note in his wallet. Will he have enough money? Now, the vast majority of us, once we're familiar with these coins and the size, you know, the amounts of money that are displayed here, will be able to say yes very quickly. We can, you know, the vast majority of people, about 90-ish%, 90 to 95% of people, once they're, you know, comfortable with the value of these coins and the value of these amounts, we'll be able to look at that and go, you know, we're less than £8 here, so we're definitely less than a tenner. That sort of estimation skill might be very, very difficult for somebody with dyscalculia, or is more likely to be somebody to be difficult. Be very, very difficult to somebody with dyscalculia. They're, you know, they're not really, short of, if they've learned and sort of happy with the calculation strategies for this, short of actually solving this problem as a calculation and working out how much money he's got left, just that glancing at it and seeing that there's no way that those three numbers can total more than £10 is going to be challenging for them, or is likely to be challenging for them. And then when we come into sort of estimating at a larger level, and when I say larger level, you know, this is something typically older kids might be meeting. You might be we're talking upper primary, lower secondary here, working out decimal calculations like this. And you can see here that somebody has tried to multiply these using columns, and they've done that by first ignoring the decimal points and just multiplying the numbers together. And then comes the question of where to put the decimal point back in, and you've got 1569.6 when actually obviously when actually it should be 156.96. lots of kids will make that mistake, but if you were to ask somebody who might be, suffering with dyscalculia, well, look back at the two numbers you multiplied. Does that number make sense in regards to those two numbers? Does that answer make sense in regard to those two numbers? They're going to find that a very challenging thing to decide. Yeah, whereas other kids may be able to bring those estimating skills in here and say, oh yeah, actually it was about 30 times 5, so it's about 150. Somebody who might be showing dyscalculic tendencies is really going to struggle to sort of judge the relative size of that answer based on the numbers in the question. And similar here with the second one. The second one is sort of definitely a secondary school bit of mathematics, where you've got John, hi John, that's you, puts £200 in a bank account paying 5% interest per year. How much will he have after 4 years? Now, I'm sure John would be absolutely thrilled to find that he has £125,000 in his account 4 years after depositing £200. But I'm fairly certain that John would also know that that's a bank error in his favour if something like that happened, and he'd be on the phone to his bank to go, are you sure this is right, for fear of spending it all and then being forced to pay it back? There's a fairly common, for those people that don't teach secondary school students, there's a fairly common misconception there of just multiplying by the rate of 5 rather than the multiplier that is needed there. But again, somebody who might be struggling with dyscalculia is not going to see that £125,000, or may not see that £125,000 is an unreasonable answer to that question, because they quite possibly have very little sense of how large that is in comparison to the original 200.
You're going to have to let me know where you bank, Pete, for me to get these interest rates, let alone these errors, in my favour. As Pete was sort of saying at the start, really, all of these things don't in and of themselves indicate that somebody has dyscalculia, and I know that we're not looking to diagnose anybody here, but that idea that these build a picture over time, really, and that's what we're looking out for. We know that incidences of dyscalculia are very underreported, and that it's one of the areas. There was some research out from Loughborough University this week saying that it was one of the areas that teachers felt least supported with, actually, and that's why it's great to see so many staff attending this session today. So as I say, I might have struggled with that question that Pete just put on about the interest rate over 4 years there. I don't have dyscalculia, so just those on its own don't indicate, but that sort of building up a picture over time and looking at these, does this pupil have a sense of proportion, a sense of scale? And place value is another one of those areas that typically people with dyscalculia struggle with. They don't understand or they find it difficult to see the structure and relationship of the numbers in a place value system. And that might be indicated by something that I'm sure many people will have seen, which is, write the number 42, and the pupil here has written literally 40 and 2 without recognizing that number on the screen, 402, is obviously a much higher place value than 42. So that's a fairly common error, misconception that again might indicate a problem with place value, and that in turn might indicate that there may be some dyscalculic tendencies there. Similarly, another typical problem, typical misconception or error that you might come across is trying to identify numbers in a particular column. Most children will be able to read that number, certainly by upper key stage 2, certainly as 37,642. But even given the words 37,642, some children with dyscalculia might struggle to identify which digit is in the hundreds column, or even what the hundreds column is. That idea of identifying proportion, as we said before, and then place value can often be lacking or a deficit.
And then obviously as kids move on from that, start to calculate using place value columns, or to start to use place value columns in more sophisticated ways, that again is potentially going to show up. So you know, a calculation like 34.25 divided by 10, which most people that help kids with maths, be they parents, or be they TAs, or be they teachers, because I'm aware we might have all of those on the audience, you are probably thinking, right, well, I'd want my kid to either move the decimal point up place, which I really we have to be shaky on there, but the standard accepted strategy now would be to move everything down one place. Well, if you're not clear on place value and how those columns relate to each other, moving everything one place or two places, divide by 100, things like that, that's going to present its own challenges that might mean that kids showing dyscalculic tendencies are going to take longer to be able to think about something like this. That strategy may not be as supportive for them as it might be for other students. And then when you go into this is a fairly, I mean, I'm fairly certain this appears, and Jon will confirm for me, I'm sure, that stuff like this appears on the Key Stage 2 SATs, but it certainly does appear on the Foundation GCSE. Jon giving his thumbs up there. It's a relatively common early Foundation GCSE question as well. And what's really going to make this challenging is the largest possible even number rather than just the largest possible number. So having to juggle keeping one of those even cards to the end in order to make the number even, and then trying to slot the rest in rather than just literally putting the cards in order from biggest to smallest. If you've got kids, certainly by the time they get to that sort of GCSE, when these sorts of questions are coming up, or during your Key Stage 3, where most kids will have got a grip of something like that, that might be something you look at and go, this kid is really, not sure on place value and that sort of thing. It's the sort of thing that you might want to look at in more detail. Muted, Jon.
Yeah, I realised. Thanks, Pete. So you'd think we'd have got a handle on this by now, wouldn't we? After several years post-COVID. Anyway, supporting dyscalculia, we're going to move on to, okay, we might recognise some of the difficulties that people with dyscalculia or people with dyscalculic tendencies might have, but what can we do to support them? And that's the key thing. And the great thing, as with most things in terms of inclusion, the things that we might do to support somebody with dyscalculia are equally going to support everybody else as well. That idea that what's good for one is generally good for everybody else as well. So when it comes to early counting, which we talked about earlier, is a common issue, can be quite an early indicator of a potential problem with dyscalculia. These are typically the things that we might do to support children. Again, these things, as we said before, will help everybody as well. So using physical objects and manipulatives in order to reinforce that one-to-one correspondence that we talked about, actually touching things, and counting them and moving them as you do so, can just help to reinforce that idea of one-to-one correspondence. Explicitly teaching and rehearsing the stable counting sequence through songs and games. Loads and loads of nursery rhymes lend themselves to this anyway, and I'm sure this is happening. But actually thinking about what we're saying in those nursery rhymes and things, and questioning, is that right? Or sometimes, getting it in the wrong order and seeing whether children can notice that you've got it in the wrong order. We all know that children love to correct us, don't we? Whoever we are in their lives, it's always great to correct an adult. So just little things like that really can help to draw attention to what's happening in those, rather than them just becoming a pattern of sounds, which is what we want to sort of avoid, really. Directly teaching the cardinal principle as well after counting, asking, so how many is that? How many have we got? Rather than just stopping after the child's counted the last number. Making sure that we're, okay, we've counted 5, so how many is that? Sounds an obvious question, but again, we know that this is an area that some children will find difficult. And I know subitizing will be happening in lots of classrooms and things, but it's one of those things that there's always an opportunity for. And anytime that you're playing a dice game and things, subitizing is, it's there to be done, isn't it, really? So dot patterns are one of the easiest ways. Dice dot patterns, one of the easiest ways to start. Then you can move on to more abstract patterns with dot patterns that are not necessarily in those regular patterns that you see on a dice, and then into tens frames as well. Can we identify without counting how many counters are in a tens frame, either by looking at the gaps where there aren't any counters, or looking at the counters themselves, depending on how many of each there are. And essentially just making sure that we're not moving on too quickly from counting strategies. It can be really, there can be a little bit of a tendency sometimes, I think, for where children can recite numbers to 20 or recite even numbers to 100 to think that they've got counting and that they can count. But actually, we know that there is a lot more to counting than just being able to say a lot of the numbers in a correct order. We really do need to make sure that those other skills are there, and that they are solid, and that children have really got them before we move away from practicing those skills.
And then John mentions the use of manipulatives there for early counting, but actually, and anybody that knows my work will know that I'm a big fan of manipulatives anyway for all students. They should be part of the normal way of working in a maths classroom right through primary and secondary. And one of the reasons for that, not the only reason for that, but one of the reasons for that is that if that's normalized, then the kids who struggle most with maths, including those that might have dyscalculia or dyscalculic tendencies, are free to use these all the way through. It can be very difficult for kids as they get older to be seen to still be using these when a lot of their peers are no longer using them. But actually, if we make this a normal way of working in the maths classroom through primary and through secondary, we will be supporting those students that need it the most, as well as supporting everybody else and all the other students in our classroom. So the use of manipulatives, you can see there the base 10 blocks, which if you've got kids struggling with place value, and particularly large number place value, they're a great way to be going. But having them available for all students removes that stigma, makes it part of that normal way of working. Or you place value, or because ideally it would be both, you place value chart to help reinforce those place value relationships between numbers. Having those available for any and all pupils means your dyscalculic pupils and your pupils that struggle with maths have automatically got access to them, and they don't need to feel like they're behind others that don't. It's just as and when we need it, that's when it's there. And it's just part of the normal way that we do mathematics in all of our classrooms through early years, primary and secondary and beyond.
Just a note on times tables, really. And again, these strategies support anybody who is finding times tables difficult. I found times tables difficult to learn by rote at primary school. It wasn't really till I started teaching that I felt really confident that I knew all of my times tables. And actually, I'll be honest, it wasn't when I started teaching either. It was when I had to race kids on times table games and things that I had to really get confident with them. So it's not uncommon for children to find times tables difficult. Children with dyscalculia find it particularly difficult because it really is just a memory test. And often those children have co-occurrent other areas that they find difficult, and one of those might be memory. So one of the things that can really work to support those children who find times tables difficult is working on strategies to calculate them rather than trying to remember them all the time. I used to find things like knowing I could remember certain keystone times tables, if you like. They tended to be sort of square numbers and things that I could recall for some reason. But if I knew that 6 6s were 36, for instance, I could work out 7 6s or 5 6s by using that sort of landmark one that I knew in order to help myself. If I was trying to multiply by 5, I know that I can multiply by 10 and halve the answer, or halve one of the multiplicands and then multiply by 10 that way. And equally, looking at things like fractions and calculating, adding fractions, we've got down here at the bottom the idea that you can simplify those before trying to work with them. Trying to spot those connections can be the tricky bit, but if we can help children to see them, then we can make maths easier. And we know that the best mathematicians do the easiest maths. That's the point of it. We're not trying to make maths hard, are we? So anything that we can do to make it a little bit easier is important. I was speaking to somebody from the University of Nottingham this week, and they've done some research which has just been published about supporting children to learn their times tables. And they found that whilst the assessed portion of the MTC is against the clock, the MTC being the multiplication tables check in year 4 for anybody who's not familiar. So most children in year 4 will have their tables checked up to 12 times 12 in year 4. Whilst that is timed and children have 6 seconds to answer the question, that they didn't find any benefit to, and actually they found a negative impact on using timed timers to help them to learn their times tables. So trying to add that sense of urgency or pressure by using timers when children are learning their times tables can, according to this study, have a negative impact. So there's no need to put that sort of time pressure on at that stage. When children are confident with them and they can begin to recall them, that's when we can start to add that sort of additional level of challenge to their times table work.
Yeah, and then strategies on number lines and things like that. One of the strategies that's great to support, again, lots of learners, but particularly those learners that struggle with maths the most, is benchmarking along the halfway. So however your number line is graduated, again, we've just gone to the graduated in tens one here, but benchmarking the halfway points to give a sense is a really powerful strategy. So if I were to benchmark this, I would be getting kids used to, as a strategy before we try to do anything else, just where are the halfways, where's the 5, where's the 15, where's the 25, and using that to support a bit of comparison. And particularly when it comes to larger values where we might be straying into maybe upper primary and certainly secondary, if we're expecting estimation of some of those larger values that we talked about before, try and make sure rounding is secure first. And this number line is perfect for trying to secure rounding, and other number lines like it. But trying to secure rounding first allows there to be a process by which, or an informed way of arriving at a reasonable estimate, rather than just using a sense that some of these pupils simply might not have. So securing rounding means that they've got that informed way of arriving at an estimate if they don't have that sense that, oh, it's about this. Yeah. And then finally, teaching metacognitive strategies alongside the core mathematical knowledge has been shown to be really helpful. And it's been shown that students who don't have these strategies are the students that struggle most with maths are the students that are least likely to go and use these strategies when they do need them. So teaching these explicitly alongside the core mathematical knowledge is really, really powerful. So how to identify and adapt to errors, how to check back through your work and identify where an error is and adapt to it, how to monitor and track when you're problem solving, how your approaches are going. Teaching them to reflect at the conclusion of a process and think, how did that go? How did that, somebody's raised a hand, but you won't be able to come in, I'm afraid. So if you pop it in the Q&A, that would be great. How to reflect at the conclusion of a process and look back at it and go, where did it go well? Where was I perhaps less strong? Where was I more efficient, less efficient? and teaching them to connect work to previous knowledge through self-questioning. Where have I seen things like this before? What have I studied before that might help me with this? That sort of thing. So we're coming to the end of our session now. Before we finish off, though, I do just want to give a shout out to our friends over at the Dyscalculia Network, because they do fantastic work in this area. A group of volunteers led by Rob and Kat. You may have seen them influencing the House of Lords debates recently and things like that. They've got a whole raft of events going on this week as part of their Dyscalculia Day highlighting and sort of exposure. Their website has got great stuff on there for you to have a look at as well, and they run regular things. So please do, if you're interested in getting more and more support with Dyscalculia and supporting dyscalculic pupils, please do go along to their website and join in with some of the stuff that they've got going on.